national journals. Welcome, ma'am.
Biostatistics with full meals. Are you awake? But anyhow, I'll make you awake by sample size calculation and there. So my session objective is to understand the need for sample size calculation, to describe the types of error in statistical analysis, and to explain the methods of sample size calculation for various research study design. So why do we need a sample size calculation? You think sample size calculation is not important? Sample size calculation, whatever result you are applicable, you can't prove the result, okay? And if an adequate sample size, which helps us to ensure an reliable, valid information. Conducting a study with an inadequate sample is not only futile and it is unethical. And also different study design needs various methods for sample size calculation. There is no single formula. You are having different formula for different study design. So as I mentioned, adequate sample size is more important. So if you are taking very less sample or very more sample, whatever is required, optimal, whatever the result you are getting is not utilized. It is an invalid one. If you are taking a sample of more than the adequate, whatever the resource if you are using is waste. Unnecessary, you are utilizing the manpower, time, and you are projecting everything on a large scale, and whatever the result is, it will take time consuming. So adequate sample size is more important. Similarly, on contradictory, if you are having a less sample, that is, you cannot generalize to the population. Whatever result you are getting, it is invalid. You cannot use it for the rest. Okay, so you won't get any additional information. Whatever the resource you are using is also waste, and the patient are exposed to a newer intervention. So moving on to the step-by-step estimation in process of sample size calculation. Okay, so the most important first step is to identify the major study variable. So first of all, if you want to take or do any project, what thing you will be thinking now? You will be thinking, oh, I want to do whether a community survey or number of samples, what study design, so many things you will be thinking. The first and foremost is study variable. So if for example, if you want to take a scrub typhus means, I want to check this scrub typhus in the community. Your main aim is to, so first I want to calculate the prevalence of the scrub typhus in the community. Okay, then, so if you doesn't want the prevalence means, if you want to check for the incidence or the association, you have to check accordingly your study design, your variable also variable. Okay. Then the next is the different types of estimation. Whether your estimate is percentage or proportion or frequency, according to that, in your sample size you have to do some minor alteration. Then you will get the result. Then the next is to indicate the expected factor for frequency. This factor of interest, that is frequency of factor of interest, that is if you are taking a larger sample for a very rare case, is very useful because we can pick up the sample from the larger sample size. On the other hand, if you are taking a common disease, you can take only smaller sample. If you are taking in a larger scale means unnecessarily your population or the study group will be more. So for rare diseases, you have to take larger sample size, and for common disease, you can take the lesser sample size. Then the next is to decide on desired precision of estimate. As morning sir has told about the precision. So it could be, precision could be 10% this side or negative or positive side. So, or you can 5% this side or that side. Depending upon that, you can increase your sample size. If you want your precision to be 20% means, your sample size will be less. So you have to take your acceptable risk. So I will be taking 10% risk. Okay. So these are all the 5 important steps you have to think for sample size calculation, and the rest 3 you have to do some adjustment in the population size. So if you are having any target population, so you have to add that target population to your calculated sample size formula. Similarly, you have to do some adjustment for your estimated study design. If you are doing for cluster type or leveled one, you have to multiply the desired study design to that of calculated sample formula. Then you have to do some adjustment for the expected response rate. What is your response rate? As the previous session, madam has told about your dropouts. Suppose if you are keeping 300 as your sample size, in that 20% or some 10% dropout, they didn't turn up for till the end of the study, you have to include them also in your study by dividing. Okay. So this I'll be telling elaborately. So moving on to the types of error and the power of the study. Already it has been dealt that what is null hypothesis, and it is nothing but there is no real difference exist and both the groups are belong to same. And we are going to this null hypothesis to that of statistical test what we have arrived. Here comes, we are getting 4 scenario. If you are correctly accepting the null hypothesis and our test report is also correctly accepted. And the next scenario is, even though the null hypothesis is false, but we have wrongly accepted it. And the third scenario is, the null hypothesis is false and we also has rejected. We have correctly rejected it. And the last, that is the final. Here, even though the null hypothesis is true, but we have wrongly rejected it. Here comes the important thing, type 1 error. So how much we can reject? For example, if you are rejecting 5%, correctly if you are rejecting 5% means 95% you are correctly accepting it. So in that 5% is 0.05, that is the alpha 1 error. Alpha 1 error or type error, otherwise called. 1 minus alpha is the confidence limit, that is complementary to that of alpha error is the confidence limit. If you are correctly accepting by 95% means you have wrongly rejected 5%. Similarly, if you want to decrease your error, that is 1%, you can increase your confidence limit as 99%. Similarly, if you want to put it as 90% correct acception means you can put as 10% wrong rejection. So now we can move on to type 2 error. This is if you are 20% falsely you have accepted. That is type 2 error or beta error. This 1 minus beta, it is the power of the study. Here we are 80%, we are correctly picked up the null hypothesis. Okay, we have correctly rejected those sample. So this comes the power of the study. Similarly, we can increase the power by 90%, and if you are increasing the power by 90% means our beta error will be decreased to 10%. So if it is 80%, there it is 20%. Similarly, by 5%, our power of the study will be 95%. This is the graphical representation of the zones of power and the error. This is the normal distribution curve where the areas of the power alpha and the beta are pictured here, and two mean has been plotted and the critical value, this we are setting it. There comes the alpha error point. So now we are going to see the correlation between the power and the error. So suppose if you want to first look at this graph. So if you want to decrease the power, your sample size will be decreasing. Then similarly, if the effect size between the two is small means our power also will be decreasing. And similarly, if you are decreasing the type 1 error, initially it was like this and the graph has been moved. So then our power area is also decreased. On the other hand, if you want to increase the power means we have to increase the sample size. by increasing this, our power area is increased, and if you are having the mean effect size is larger means our power area is also increased. And similarly, if you are keeping the alpha error is more, then our power is also increased. This area from this critical value from here it has been moved towards this blue line means we are increasing the power. So moving on to the calculation for a single group continuous data. For example, if you are taking 0.5% rho p vacant for looking for sensory blockade, these are all the things we want to check. These are all the information needed. First is the accepted alpha error and accepted standard deviation and expected precision of margin. So suppose if you are keeping the alpha error, what I have told, alpha error is 5% and we are keeping it as 95% confidence limit. So this is the value 0.05 we have kept, and the expected standard deviation is 50%. Initially I told the precision of margin could be at 10%, 10 to 20%. So we are keeping here as 10%. Using this formula, that is z square 1 minus alpha by 2 into standard deviation the square divided by d square. D square is the precision of margin. By applying this, substituting this value to this formula, we are getting the sample size as 96. Then moving on to proportionate group for single group. This proportion already they have mentioned on whether it is yes or no type. So we are taking this tramadol 50 milligram, whether the incidence of vomiting is present or not. So we are checking the proportion. What are all the information needed here is same like that, alpha error and expected prevalence of the proportion and expected precision of margin. Similarly, we are taking the prevalence, that is 2 out of 100 people they are getting vomiting. So prevalence is 0.2 and the precision of margin is 10%. Using this formula and substituting this value, we are getting the sample size as 62. And now we are going to the two groups. Initially we had single group, now we are going to calculate for two groups continuous data. Here, bupivacaine, 0.5% bupivacaine heavy and 0.75% ropivacaine heavy. We are checking the sensory blockade. What are all the information needed here is same alpha error, and here we need power of the study. What is power? Power is correlated between the beta error. If you are increasing the power, values will be more reliable. And the expected standard deviation and the expected difference, that is the effect size. That is the difference between both the groups mean value. So we got this value, and using this formula, z1 minus alpha by 2 plus z1 minus beta the whole square into 2 into standard deviation the square by d square, that is the effect size. So by substituting the value, we are getting 35.28. So approximately we are rounding up to 35. Suppose if you are increasing the power as 80, from 80 to 90, we are having the sample size increased. If it is 80, we are having only 35 as the sample size number. If you are increasing the power, then our value is also increased. And similarly for two groups, two proportion. Same example, now here we are taking tramadol 50 milligram and tramadol 75 milligram. Which one people are getting vomiting incidence higher? So the information needed are same alpha error, power and expected P1 and P2. What is the difference between the two groups? And using this formula and substituting all this value, we are getting 96 as the sample size. Then moving on to the various other types of studies. In observational study, for example, case control, cohort, cross-sectional study, we have to do some minor alteration in the sample size calculation formula so that we will get the result accordingly. Similarly, in trials like superiority trial, equivalence and non-inferiority, we have to do some slight modification so that we will arrive the sample size calculation. And for diagnostic test and reliability studies also, we have to do some minor modification in framing the calculation. Then when do we use software for sample size calculation? Previously and all I was telling, we have to apply it on the formula. Here we can use only the software. Whenever the study is getting complicated, we are going to take for larger measurement. So we have to use sample size. We can't use manually. For example, in longitudinal study, where we are using repeated measurements, where we are going to take repeated measurements in a single person. For example, if you are going to check the time at 0 hour, 1 hour, 2 hour, what is the effect? Or treatment, whether if you are giving before propofol, what is the effect, and after propofol, what is the effect? Similarly, spatial, if you want to check the BP of right upper limb compared with left upper limb or lower limb. So, same person, if you are using for repeated measurement, here we can't use the manual method. We can use the longitude software for calculating this. And similarly for clustered level, clustered or leveled one. Here, various groups, as morning madam has dealt, no, in that they have shown in one picture. Here we are taking, I suppose if I want to take the weight of the students, school going students, and that too I want to take in 4 districts, out of 30 districts, only in 4 districts I want to check. From the first 4 districts I want to choose only 3 schools. From the 3 schools I want to take only 2 sections, and from 2 sections I want to take 20 students from each section's main. I can use this cluster. This is called clustered type. Here also we have to do slight modification. We have to use software for calculating. And varying group ratio. Here, suppose if you want to take 3 groups, no need to take 20, 20, 20 for each group sample. Here 1:1:2 ratio also can be used. No need to equally distribute the sample size. For example, if you are going to take 100 as the sample size, you can group as 25, 25 and 50. Like this also we can do our grouping. For example, if you are taking the NEET coaching, here we are taking 30 students. So we want to assess the how exactly the students are studying in the NEET coaching means we can use this type of study. For example, before going for the NEET coaching, then after 1 month, then after 6 months, what is their progression of their studies? So here comes the correlation between the repeated measurement. Here we are choosing the same students, but same student is getting 3 times mark. That is before, 1 month after, and 6 months after. Here we are using correlate.